this slidecast we're going to look at engineering estimating methods. How do we do the estimating? There are several ways of doing it. The roughest way, the easiest way of doing it is analogous estimating. Client walks into your office, says, I'm building a 2,500 square meter commercial building in Hamilton, how much? And the only information you'd have would be the plans that he provides of the site and maybe a site walkover. You may not have geotechnical information, you may not have detailed survey information. The building hasn't even been designed, so you don't know what quality of materials are going to be used, you don't know what the layout of it's going to be, you don't know how difficult it's going to be to build. You've got a general idea. He says, I don't want it too fancy, but I want it functional. So there's not that much information to go on, and the only thing that you really have that can allows you to give a price is your experience. So you would say, okay, well, we built a 3,000 square meter commercial building in Auckland for 4.75 million. So what you know is this building here in Hamilton is not going to be $1 million, it's not going to be $10 million, it's going to be somewhere around 4.75 million. So analogous estimating gives you an idea of, yeah, it's around about that much. You'd actually round it up for the client. You'd say, oh, about a 5 million, or even you might round it up a little bit more and say it'll cost you about 6 million, because obviously you want to go a little bit high. So that's analogous. It's this building is analogous to that building, but there are a lot of inaccuracies to it, but sometimes it's the only option you have. The next method is bottom-up estimating, which is the most accurate way of doing things. Oftentimes this is the method that contractors would use to develop a new rate for a work activity they're doing, but engineers can also do this for estimating as well. What it requires you to do is to build up an estimate from first principles, to think about how is the contractor going to build this, what sort of resources is he going to need, and how long are these resources required to be used on the particular activity. So in this case we've got a demolition. We're just doing a lump sum for this one. We figure we need an excavator, 2 trucks, a supervisor and 4 labourers. We know what when we say, okay, it's probably going to take us about a week to do it, so we've got 40 hours there. We know what the rates are. The rates for these sort of things are pretty well known in the industry. There's a source called the Contractors Blue Book, where every year the Contractors Federation puts out the rates for particular types of machines and labour. Also in a contract, the contractor will have submitted rates under day works. So these rates are pretty easy to find out. So you figured out the time, you multiply the time by the rate to get a cost. It's not daily cost, it's total cost. Add all the costs up and you get a figure of about $18,800 for that particular activity. So what we've done is we've built it up. So we've gone from the bottom, we've built up an estimate from the bottom. This does take a lot of time and a lot of experience to be able to do it. It's not the easiest way of doing things. The way that's normally used is what's called parametric estimating, and that's what we're going to talk about now. A parameter is a measurable factor. So for example, a measurable road, you can say measure a road in kilometers or in meters. So the parameter there would be kilometers or meters. A building, you can measure it in square meters of usable area. In this case the parameter would be square meters. So the process is that you determine an appropriate parameter. You look at a project and you say an appropriate parameter for that would be square meters. It's building. Or a road, we could say appropriate parameter would be per kilometer. Then you determine the project size. So you'd say this is a 2 kilometer long road. That gives us a quantity. And the last thing you need to do is to find out a rate for that particular parameter. So you say it costs about $1 million per kilometre of road to build, from my experience. And so you times 2 by 1 to get, you multiply the quantity by the rate to get the project cost. So that's if you're estimating a whole project. This parametric estimating process also works for individual items as well. So the way we normally use it in a project is we use it to build up our schedule of quantities. So you should recognize this as an excerpt from the schedule of quantities. We've got a whole lot of little work items here. We've determined appropriate parameters for them. we've measured those parameters from the drawings, much the same way as you prepare a schedule of quantities. We've done exactly the same process. But now, because our clients asked us for a price to do this little job here, we've broken it all down, this is what it is, he wants to know how much it's going to cost. So we have to figure out rates for them, and we'll talk about how we determine those rates in the following slide. But let's just assume that we've found out that it's going to be $8 per square meter to strip topsoil and stockpile. So we multiply the 800 by 8 to get $6,400, and we do that for each one of those line items, add them all up, and there is our price for the whole job. Now, one thing about that parameter rate is it needs to be appropriate for what you're actually doing. So if you're building a 2-lane highway and you say, okay, well, a road costs $1 million per kilometre, does that mean that's $1 million a kilometre when it's just a little lane like this, or is it for a 4-lane highway? You need to make sure that the parameter you're using, the parameter rate that you're using, is the same or similar to what you're actually building. So if you're building a 4-lane highway and you have a parameter rate of $1 million per kilometre for a 4-lane highway like this, then that's fine. But if you're building a little lane, then it's not. So you need to make sure that you understand what the rate you've got actually involves. Now we're talking about how do we determine what those rates are, and there's different ways of doing it. The most common way of doing things is from previous projects. You will have or your company, if you're working for a consultancy, will have the tender submissions from previous projects. So you'd go through those and you'd find out what previous contractors have put in for it. So in this case, you might be designing a road, and you need to figure out how much it's going to cost for the base course. You go back to a previous job and you find that item 403 of this previous job is very similar to the item you're trying to price now. So you pull that price out there. You might look at that and say, well, this project happened a couple of years ago, I need to up this because inflation means that it's probably a bit more expensive to build a road now. You might look at it and say, well, my project is only about 50 cubic meters, so economies of scale would dictate that I need to put that rate up a bit more as well, because this is for 500. So you need to adjust it for time and size, and we'll talk about that in later slide casts. Another way of doing it is if you don't have previous rates or applicable previous rates, then you can work it out from first principles. In this case, we know that the quantity is 1,000 cubic meters. The duration is, from experience, we know it's going to take about 5 days to lay it. So once again, the resources from experience, we know there's a foreman, couple of labourers, this plant and this material. So we once again do the same process as we did with the schedule of quantities. We've got our units, our parameters. We figured out the quantities from the drawings and from our experience, how long is it going to take us to do it, and we've got this quantity here off the drawings like we did the schedule. We find out the rates from the contractor's blue book or from previous dayworks rates, multiply the quantity by the rate to get the amount, add all up, and we get a total price of $99,250. Then we divide that by 1,000 cubic meters to get a unit rate of $99.25. So that's the number we'd put into our estimate. Personally, I'd round it up to $100. It's always good to round up rather than round down. If you do not have the experience to do first principles, or you do not have previous project information, the third best option is to use what's called industry publications, and the one that we use is Rawlinson's. Rawlinson's is a book put out by Rawlinson's quantity surveyors. Every year these guys go through and they price up different types of work. So in this case they've said laying base course on a road 150 mils thick in Auckland, it's going to cost you about between $9 and $9.60 per square meter. Now it's a little bit thicker than what we were looking for, but it tells us that it's going to cost us between $9 and $9.60 per square meter, or sort of $90 to $100 per cubic meter. So that gives us a bit of a ballpark figure. We know it's not going to be $50, we know it's not going to be $200, we know that sort of area that it's going to be. Then we'd use our experience to come up with a rate. But as I said, this Rawlinson's is by far the third best. These two options here are much better, but sometimes you're stuck with just the Rawlinson's one.